Nice. G'day. Hi, David.
Hi Glenn, how are you?
Good. This is David Norman from Discover Battery, and this is a very interesting battery. I've got one of these at the lab. I've been playing with it for a while, but David, tell us about this battery. What's special?
Okay, Discover's AES Battery is specifically designed for off-grid, microgrid, and diesel abatement or remote power applications.
Yep.
It's more robustly built than most of the residential lithium batteries. It's LFP cells, it's a 48 volt battery bank. This particular model is a 6.65 kilowatt hour or near 7 kilowatt battery. And again, designed specifically for off-grid applications to pair with hybrid inverter chargers.
So you can parallel multiples of these together to get more storage, more power?
Yeah, virtually, I mean, to any practical limit that you would want to expand a residential off-grid or a small microgrid system to, you can simply parallel these batteries. Code compliance in keeping that in mind. There are several different methodologies you can do. We are capable of doing battery-to-battery paralleling,
yep.
Electrically speaking, or running these to a common bus bar, a single point of common contact.
Okay.
In terms of the actual battery itself, there's two parts to the connection. There's the electrical component of it, which is your DC cable runs.
Yep.
And then there is something else to consider that's unique to this battery as opposed to most, and that's the communications networking paralleling of the battery.
Okay, let's come around and have a look at that. Let's come around the side here. A little closer
Yep.
in. That's good. Okay, so tell me a bit about the communication sides. I noticed there's some ports here on the top.
Yeah, so this battery can be used in, I guess in Australian terms, a managed or an unmanaged mode. Okay, unmanaged mode, it just operates as a lead acid battery replacement. Simply the terminal connections are reporting voltage and the like.
Okay, so no special comms that'll work with any inverter that works with a
Yeah.
48 or
Total
24 volt versions?
Totally capable of retrofit any traditional or existing lead acid system.
Yep.
No comms, any vintage of inverter charger, any make model of inverter charger, no problem at all. Simple setup, just configure it for bulk absorption and float as we direct in the manual, and you'll have a battery that's going to operate, to 2 and 3 times the capacity of a lead acid battery and recharge 4 to 5 times quicker.
So you can also, using this AE bus, use it with a managed system with a compatible inverter?
Exactly. So we have 2 CAN channels on this battery built into the board. AE bus is Discover's proprietary CAN protocol,
yep.
And we use this bus, again, just RJ45 CAN network connection, to aggregate or to gang multiple batteries together. That has them basically report as a single battery block.
Yep.
That's kind of important because with CAN you have some traffic limitations. Rather than having each battery incrementally adding that traffic onto the network, what we're doing is aggregating the batteries, so when we do connect to an external network, we're connecting it as one node or one block.
Okay, so you really can scale these a lot in that regard.
Exactly. So the other that you'll see on this is a specific example. We actually have Schneider Electric ZANBus built into the board here.
Right, so very Schneider friendly, straight out of the box.
Yes, exactly, and that kind of comes with some of the lineage of the personnel that we have and how we're co-located to them in the Vancouver, Canada area.
Yep.
But it'll give you a good example here, to give you a good example of how that works. So we would gang several batteries of these together,
yep.
Have them report, and then we would simply connect or designate one of those batteries to be the ZANBus node. You plug in the ZANBus network to this on a terminated network connector, and essentially as soon as you did that, we would broadcast, you would see our Discover AES battery appear on the system control panel or COM box. We would push and auto-populate all of the settings and configurations for that inverter system. So in this case, it's a 130 amp hour battery. If we had 2 of them, it would represent a 260 amp hour battery automatically.
I remember this happening to me, and I thought I had to program it, and I couldn't change the settings.
No.
And I think I emailed you about this, and you go, no, we tell you the setting. We tell the inverter what settings.
Yes, exactly. And for, I guess 2 things. First of all, for the average installer, it takes away time, scrolling through all those menus and things, and it also takes away the human error in terms of just missing a step in the setup.
Yep.
Furthermore, homeowners are prone to tinker.
Yep.
And at least for the critical settings that we want for this, you have an inability to overwrite those fields. So the ones that are critical to us and what we want to see from a charger's perspective are you cannot change. The batteries are telling the inverter what it wants to see and
now,
what that parameter should be.
You've got a few boxes here. What's this one here? Let's get a little closer look at this.
Perfect.
Tell me about this.
So this is our link device, and again, we talked specifically about an example here where you have ZAN bus. The link device essentially acts as our other channel. There we go, our other device channel that allows you to export to other networks that aren't resident on the BMS. So in this particular case, we can do the same level of integration with Victron's platform, Sunny Islands. We could look at Studer Innotech, at this point in time, all the major CAN-based communication protocol power electronics manufacturers are integrated. You'd simply, again, you disconnect this, you'd populate it with an edge card that's power electronics specific, and then basically connect that network just as we suggested here with ZAN bus on our battery, and it would allow you to do the same level of integration. Again, pushing settings and configuration, device configuration for you, having all the data aggregated over their third party or their collective system monitoring for this device. And the thing that is very unique to this, rather than just broadcasting SOC and status, we actually, when we're talking about a closed loop or a managed battery system, we're doing more than most batteries do. We actually become the master, and those power electronics become the CCCV slave to what our battery wants to see. So throughout this is primarily a feature of recharging, right? Lithium is so much faster than lead already, but the holy grail for off-grid systems is fast recharge. So what we can do when we're able to dynamically recharge is we take the information that's already on the BMS, cell voltage, cell pack temperature, and cell spread in terms of any kind of deviation in cell voltage spread. If the battery conditions are good, we can actually change and put a very dynamic or a very aggressive charge profile in, a higher voltage, say. Normally, let's say if it was a static or unmanaged battery, we would put in a setting like 54 for bulk and absorption. In this particular case, when it's dynamically controlled and the battery is driving, we can get up into 57s in that nature as well, barring conditions are met for it, and have an aggressive charge that typically reduces recharge time by about 25% compared to an unmanaged battery, lithium battery.
I notice also you've got a little display on the front, so this is also a simple display.
It also acts as an on-site SOC meter. So and it's aggregating the however many batteries you have. So it's not a device dependent thing. You don't need one-to-one with your batteries. This would take whatever size battery bank and represent the whole as a block combined.
Cool. So what's under the hood? There must be some special electronics inside here.
Yeah, so the claim to fame with our off-grid battery, and when you're designing an off-grid battery, the specific things you want to take into consideration are current carrying capacity, all right? So this is a 6650 in terms of watt hours is representative of 130 amp hours. In that, this battery can do 130 amps DC charge and discharge continuously. So that's 1 C rating. Okay. We also have the ability to surge to about 3C to handle motor loads or in-rush loads that are demanded by your power electronics.
That's a great feature for off-grid. So those surge loads really kick in. So you've got some boards in front of me here. Let me just change angle.
No problem.
So I'm going to film this way now.
Okay.
So you can hold those up.
So, again, in talking about the high surge capability of this battery, one thing you will notice about this is our switching board, or basically our switching solid state relays. Okay. What we're doing with this is, basically enabling, or this is the primary protection for the cell block in the battery. As you can see, there's very robust bus bars in there. If you just give that a feel compared to most battery BMSs. You're probably 3+ pounds with this, right? Or 2+ anyway.
Everything about the battery feels really solid.
Yeah, exactly. I mean, down to the steel case and everything like that as well. Again, it's an off-grid battery. These are simply just heat sinks on top of our FET banks. The FET banks are a solid state switch. It's a way of switching the power from the battery by digital control. either for protection's sake or for controlling power flow. On top of that, inside the battery, you would see the control board, digital control board. This is where all the comms that we talked about before are managed. This is where we're doing all of the data logging and recording for the battery's status over time. And this is essentially what's doing all the algorithmic controls that we would want to use the power board for. Our engineers would probably be shuddering right now. They probably don't call it a power board, but I come from the inverter side, so it's got MOSFETs and heat sinks. It's a power board. One of the things in sort of breaking this apart and showing this to you is not only to show like sort of the quality of the BMS and the controls that are built in, but inherent in off-grid installations is you're typically dealing with remote sites. When you're dealing with a remote site, uptime is everything because transport to and from is very difficult. This battery is unique compared to the myriad lithium batteries you'll see here at the show, in that it's completely field serviceable. Should anything happen to the battery, the cell block is the holy grail. This is what we want to protect the most, as it's the most expensive and also it's dangerous goods to ship. So all of these devices, and the boards, the fusing, everything like that that's there is designed to protect the cell block to the nth degree. To do that, sometimes we will sacrifice. If the system is undersized, for instance, and you happen to have a single battery with a single inverter, and you were to run that at, say, and I told you this would do 130 amps continuous. Let's say you had a charger that was pushing 150 amps on a continuous basis. Well, eventually, the battery is going to heat up. It's going to stop. And what's going to happen here? It's not enough to basically have this disconnected power, but you might blow the fuse. If you did that, again, rather than having to ship a 90 kilo battery, disconnect it from the wall, put it in its packaging material, have the dangerous goods guy pick it up, bring your replacement battery, and you'd simply pop the cover off and replace it with a $10 auto fuse that's 150 amp rated.
You get for your local auto electrician.
Exactly. So what it does, it makes it possible for off-grid people. Again, uptime is everything. It's your critical power.
Yeah.
Having a small reserve of some replaceable components in the event that there's an emergency, in the event that, let's say, you had a dead short somewhere in the system and you overloaded the system, in the event that you had a lightning strike and it took out your comms by the Ethernet cables that are attached to this, the boards are all field serviceable and replaceable without any technicians or qualified personnel. You can do this yourself, so you can have your batteries back up and running very quickly.
Well, thanks, David. That's been excellent. Really learned a lot about the battery.
It's always my pleasure seeing you down here at these things. I've enjoyed working with you for years now, and it's nice to see you at a show like this.
Great.
I'll see you again next year.
Indeed.
Wonderful.